In this video we're going to look at lines of best fit. Now when you take a real situation and you draw a graph, you sometimes see that the points suggest a line but they don't make an exact line. And what you'd like to do is, for the sake of coming up with an equation, you want to consider a line through them. Well, that line through those points is called a line of best fit, and we're going to look at two different methods of getting a line of best fit, and we will get two slightly different answers. But for the data we've collected is about the height of a seedling in a pot, and it's measured over a 10-day period, and I'm sure it's one of these super seedlings that can just grow each day remarkably. And we're going to use the two means method to come up with a line of best fit. So we need to split the data in half. So these are points. If we were to draw this graph, we would have days, or time should really be, time in days on the x-axis, and we would have the height in centimetres on the y-axis. So that means this point here is 0,12 and 1,13, etc. Alright, that's our x, or that's our independent variable, and this is our y, and this is our dependent variable. So we need to split this data in half. We have 1, 2, 3, 4, 5, 6, 7, 8 points. So we'll split them here into two lots of 4. So what we need to do is we need to come up with like an average x and an average y for this lower half, and an average x and an average y for the upper half. Now I'm going to speed this process up a bit. I'm just going to give you what those are. So the average of 0, 1, 2 and 4 is 1.75, and the average of 12, 13, 15 and 17.3 is going to be 14.33. So that's the lower mean. Now the upper mean, the x1, the x coordinate is the average of 5, 6, 8 and 10, so that's 7.25. And the average of the y is 22.25. Okay, so working out the slope, we now go back to the method that we used in the previous slide. It's just that in the line of best fit process, we're just deciding on a way of getting our 2 points, and then we just go through the same method. So we need to find the slope, so it's 22.25 subtract 14.33 over 7.25 subtract 1.75, and doing all that work, that comes out at 1.44. So finding the y-intercept, we know that if we so far we've got y equals 1.44 x plus c. So if we take one of these points and substitute in, we know that 22.25 is equal to 1.44 times 7.25 plus c. Rearranging that, etc., etc., we know that c will come out at 11.81. So, and using the pronumerals h for the height of the plant after d days, we know the equation will be h equals 1.44d plus 11.81. Alright, that was the two means method, and it's a method that's not used that frequently. One that's used a lot more frequently is finding the line of best fit by eye. And when you do that, it's quite tricky. You need to put your line through such that about half the points are above the line and half the points are below the line at both ends of the line. So you can't see what I'm doing, but I'm overlaying a ruler on top of the screen here to try to attempt to do that. And because I have those things worked out ahead of time, I'm going to put in by eye what I think is the right one. Okay. And when I've done that, I've noticed that, yeah, I've got a point below here, I've got one above here, one below here, and this one's in the middle. I seem to have picked up a few points as I've put the line through, and that's really useful as well. So I'm going to use this point here because it's the Y-intercept, and it's a true Y-intercept because it lines up with an X coordinate of 0. So this is 0, and that point was 12. That was the first point. We're using the data from this table here. And I'm going to, spread the points out, and the line goes through this point here. So I'm going to use that as well, and that's 8,23. All right, we can see that that was in the table as well, 8,23. So I'm going to use those 2 points to find my line. So that's it. I'm back to that very standard method now, finding the slope. And I don't need to do that again. That's pretty routine. But what I might do this time, because it will just illustrate to the point to you what slope is all about. This line runs from 0 up to 8, so that's 8, and it rises from 12 up to 23, so it rises 11. So the slope here is equal to 11 on 8, which is equal to 1.375. I'm going to round that to 1.4. And then because the point that I chose on the line that I chose went through this point, which was on the y-axis, I've got my y-intercept. So my y-intercept C is going to be equal to 12. So that makes this equation y equals 1.4 d for days plus 12. Okay, I think that's a little bit off the screen. I'll just bring that over. Okay, so the height of the tree is 1.4 times by the days it's been growing plus 12. You'll notice that that is slightly different to the same question that we did using the average method. 1.44 was the slope as opposed to 1.4, and in this one y-intercept's 11.8, in this one it's 12. Very subtle difference. Which one's right or which one's better than the other? Very difficult to say, but certainly with the two average method, it's a reliable thing, and you can get this answer, and the person next to you and the rest of the class can get that same answer. With a line of best fit, everybody will get a slightly different answer because we will all have different interpretations of where that line will go. So we'll all get different answers. What usually happens though is some people will be more accurate than others. And when you get to the end and you start reflecting upon, your line and your answers and all those sort of things, you may actually sort of say, oh, look, I could have drawn a better line than that. But anyway, next video we'll look at a computer-generated answer.